Hey there, techies of the modern world. Welcome to my channel. I am a solution architect working for a top AI company in the field. Welcome to my course, Computer Vision Unleashed, where we will be discussing and unraveling the mysteries of computer vision and AI. I think you must have heard the term quite frequently recently, but trust me, I've been working in this field for quite some time, and today we'll be diving deep into the captivating world of computer vision, which is fascinating. Get ready to explore the discipline of AI behind this revolutionary technology that's changing the way we interact with the machines and the world around us. So, what basically is computer vision? Computer vision is like giving your computer a pair of super duper ultra fancy AI powered sunglasses. So, imagine your computer is sitting right there and Eureka, I can see, the computer yells at you. Right. So computer can see now just like you do. But instead of enjoying the scenery or ogling at the cutie puppies, it's analyzing pixels, shapes, and colors. Let's go more technical. Computer vision is a multidisciplinary field of artificial intelligence. Artificial intelligence has various fields like computer vision, data science, NLP, and etc. But this field especially empowers computer to extract information and meaning from visual data such as images and videos. I think you must have heard about multimodal data sets too, but we'll dive deep dive on these later. The primary goal is to enhance the machine to see and interpret the worlds, like the visual world, in a way similar to what humans do. At its core, computer vision involves a series of complex algorithms and mathematical techniques that process and analyze the visual data. Here's like there are some technical components involved. Currently, you can see that how a human brain works and how a sensing device enables the computer to see this input images. But to interpret these images, we need a certain algorithm to do so. How we do that, we will explore this in this course. And of course, basically going into deep technicalities is what this course is all about, learning the technicalities over those so-called AI gurus in the YouTube channels that are only using the AI tools available to them, and they are just creating an audience out of it. But as in the book mentioned, from zero to one, when you know how to build systems from zero to one, that is much more meaningful than using those systems. So let's dive into some of the technical components involved when we try to do computer vision. So there are we'll go each and every technical details of it, but since it's the first lesson, I'll not bother you with all the technical terms and just try to tread it lightly. The image acquisition is the first step when it comes to computer vision. Like computer vision begins with the acquisition of visual data, which typically comes in the form of digital images, video frames captured by cameras, sensors, satellites, etc. So after acquiring those images, we process those images, do image pre-processing. These raw images contains noises, artifacts, and irrelevant informations. So we don't need that in our data, and we try to clean it and pre-process these images. So there are various techniques we will be discussing about, like normalization, color space conversion, image enhancement, quality enhancement, and removing unnecessary elements using GANs. We'll be talking about these in this course. So after we acquire these images and pre-process these images to extract relevant information, we do this feature extraction, what we technically call as feature extraction. So in order to understand the content of an image and relevant features, we extract these features like patterns or edges or corners, this texture information of a cloth, or more complex ones like the facial recognition algorithm. We extract the features, the key points that is common to every human. So these common key points are detected, corners or edges for objects are detected, and through those we try to extract these features. So earlier what happened was, without a deep learning, the process was pretty complicated. The OpenCV libraries and other libraries were there, but the thing is, in that route we had to go image by image, or very to learn complex features. There was a difficult process to learn these complex features, since there was like the data was limited. But with the recent evolvement of cameras and the computing, we are now able to learn these complex features one by one. The deep learning has pretty well played a great role in this. So after we extract these features, the computer needs to understand them. That's why we need a feature represented methods, like the extracted features are presented in a more suitable format. So the common representation techniques involves vectors, matrices, higher dimensional tensors. So these are some of the feature representations. So what did we see until now? We acquired the images, we then pre-processed those images, we then extracted relevant information features from these images, we then represented those images and the features for further analysis in some form like vectors, matrices, or high dimensional tensors. So what do we do with that information? We apply it, these features, what we have learned, the representations that we have learned, into some algorithms. We try to create algorithms which are able to detect, like object detection and recognition is a very common use case nowadays. The object detection involves locating and identifying specific objects or patterns within an image. So this is typically done by matching detected features against a pre-trained model or using the deep learning based methods we'll be discussing, like CNNs, convolutional neural networks, etc. So coming to the there are many more applications we'll be discussing, like image classification. Like there are various deep learning and machine learning models to recognize patterns and assign the correct label to unseen images. Then there is image segmentation, pose estimation, uh, and the recent the much more recent and hyped technology, generative AI and 3D computer vision. So just let me quickly go through what image segmentation is. Here, in image segmentation, we divide each and every image into meaningful regions, grouping together the pixels with similar properties. So this process is vital for any segmentation task like semantic segmentation or segmentation. So the 3D computer vision branch deals with capturing and understanding the three-dimensional structure of objects and scenes. So techniques like stereo vision, structure from motion, LIDAR, these are used for basically 3D reconstruction. So the deep learning has revolutionized computer vision by enabling the development of highly accurate and robust models. The CNN and other deep learning architectures have become the state of the art for various computer vision tasks. So the applications of the computer vision we'll be discussing one by one, such as autonomous vehicles, healthcare, robotics, surveillance, augmented reality, and many more. So overall, the computer vision is a very fascinating blend of image processing, pattern recognition, and machine learning and AI that enables computers to analyze and understand the visual world, which is opening up a plethora of opportunities and real-world applications. So stay tuned and let's roll.